So today class you are going to learn about the MOSFET and IGBT, one of the power semiconductor devices, MOSFET and IGBT. Okay, last class you were learn about what you were learn. So yes, first unit power semiconductor related. You were learn about two device. One is SCR and GTO. If I have see SCR and GTO, these two is a current control device. That two is a current control device. Okay, so that too is the current control device. So current control device, if I am going to draw the diagram, drawing control, yes. So draw the diagram. So if I have draw the diagram, first one is you will going to draw about the SCR. So this is the anode and a cathode. This is the anode part and this is the cathode part. Yes. So that's all. So this is a diode and diode here you will going to form. This is called the SCR. So gate terminal and anode part and cathode part. Okay. So this is about what is this one? This is a SCR. The next one GTO. What is a GTO means? So here is a one slash, you can put it on GTO. So this is a one slash, or it is nothing but it is a double side arrow mark. This is a GTO. Okay. Then what did you do? So here is the output of the device. Anode to cathode is the output of the device. Okay. First once again I will going to repeat. Okay. There are two devices you were seen in the last class. One for that one SCR, second one for that GTO. One for that SCR, another one is a GTO. Yeah. So SCR and GTO. So these two you were seen. Okay, this two is a current control device. Okay, so we're going to revise about that. These two is current control device. Okay, so why it is current control device? Then first one, what is the difference between the SCR and the GTO? So SCR is nothing but first symbol wise you will going to learn. Okay, so I will going to draw this a symbol. This is about the SCR. Okay, first diode I have draw. Then after that I will going to draw about that SCR. Okay, symbol that is called a gate. If it is gate is there, then that is called SCR. If no gate means that is called only you can say about diode. Okay. GTO means what? The same SCR I will going to draw. Okay. I will going to draw the SCR and after that gate terminal also I will going to draw and then I will put it on this slash. This slash indicated as about that one. It's a okay gate terminal inside as well as outside. Or you will going to redraw that one diagram. So this is about yes. So this is about that okay anode and cathode. Okay, what is meaning of that gate terminal? I will going to draw gate terminal. So inside arrow mark and outside arrow mark. So this is a total about that one. Okay, this is about GTO. Okay, you will going to represent it like this one, or you will going to this is the meaning. So inside arrow mark, outside arrow mark. Here is a no arrow mark. What is the difference? SCR is a controlled on. You will going to on through that gate terminal, controlled on, and once it is on, you will going to remove this one gate terminal. Okay, you can't to off the SCR. You can't to off the SCR. SCR you can't to off. That's why it is uncontrolled turn off device. Uncontrolled turn off device. What is this one device? You will going to use for that this is a arrow mark used to you will going to turn controlled on and this arrow mark it is used to you will going to off. So off means the negative bias you will going to use to you will going to off. So controlled on and controlled off both also possible. This is the differentiation. Controlled on and uncontrolled off, controlled on and controlled off. There are two arrow mark I have represented. That's why there are two arrow you mean two tick. So controlled on and controlled off. Okay, so this is about the GTU. Okay, then what next one? If I have see that one, this is anode cathode, only one bias. So here you will going to connected to the source. Okay, so this is nothing but it's a one switch. This is nothing but this is a switch. Switch is what is the purpose? On purpose and off purpose only. So here I will going to give the power supply. What power supply I will going to give? So I will going to apply the AC power supply because AC consists of positive magnitude and negative magnitude. It will going to interchange. Okay, it will going to interchange. Cycle is a phase with respect to neutral. Second half cycle is bottom is phase with respect to neutral. Shall I going to connect it directly to that switch? No. So shall I going to connect the switch directly to the source? No. Why? What happened? So switch it is a close means it's a source would be short circuited. See, when switch is closed, yes, what happened? Source is a short circuited. Then what to do? Any cause switch should not be directly connected to the load. Any cause switch should not be directly connected to the load. Then what to do? then you have connected one load here. Yes, if I have connected one load, okay, this is a fan. See, your fan, you have that one, you have fan, tube light, everything you have. Okay, if I have for example table fan means power supply plug point available, table fan available. Table fan, that table fan consists of that two wire. Okay, two wire also available, or three wire available. So two wire I will go to connect it directly. Okay, if I will go to connect it directly, okay, if switch is on, the table fan is on. If it switch is on, the table fan is on. Suppose I don't want to that one, if I have see that one, it is a switch box. I have developed one switch box. The switch box is consists of the more number of socket available. Okay, more number of the socket available, but I'm not developed with any switch. I don't come with any switch. The fan I will going to connect it to the plug point. So whenever the plug it is I got connected automatically on. That means no switch is there. No switch is there. Okay, this is a plug point. So like so if you have, if you want the switch or not, so if you have switch means on and off. So I remove the switch in the plug point. So once I will going to connect the wire, the fan is on. So like for example ceiling fan, I will tell you about the ceiling fan. So ceiling fan, how it is connected. Okay, power supply to the switch, and switch to the fan. So okay, switch to the fan. Power supply to the switch to the fan. Okay, and the neutral is directly connected to that power supply. So this is a method of the connection of the ceiling fan. Okay, this is the method of the connection of the ceiling fan, similar to tube light, whatever you can say. The switch is needed. If you are, I'm going to remove the switch means what happen. So every time 24 hours, whenever power available, the fan is operated. If I will going to remove the switch, what happen? Whenever the power available, okay, power available, the fan is operated. So that is the meaning about that with the switch and without switch. Yes. Okay, this is the difference between with the switch and without switch. So this is about that. Okay, yes, yeah. Okay, okay, so switch important of the about the switch. Okay, then coming to the point. Okay, first I will going to draw, okay, one device. Okay, and coming to that power supply wise, I will going to explain. Okay, here is a gate terminal. Okay, so once you will going to apply the gate triggering, so the R triggering method, RC triggering method, or the UJT triggering method, whatever type of the triggering method you can give. So once you will going to give the triggering through that one, okay, small power supply, DC power supply you will going to use to give. So DC means continuously you will going to apply. AC means it will going to change the current. Okay, we will going to give that one triggering. Once it is giving means it is on. That's all. It is on. This, that's switch is closed. Okay, one switch is closed. Here is the one lamp, that is our motor. Whatever you have take it load. This is a load through that one power supply. Through power supply, when you will going to connect it. If you connect it means it will going to off cycle. AC consists of okay, one cycle consists of positive off cycle. During the positive off cycle, phase is a top with respect to neutral and bottom. So current is a flow. Okay, in directly low power supply, phase to the load to the switch to the closed circuit. So during the condition, okay, during the condition, SCR is a forward bias. So forward bias means it will going to permit you. So permit for that one, same permitted. Yes, that's why off wave. It's nothing but a off wave controlled rectifier. It's nothing but a simple to say off wave controlled rectifier. What about negative off cycle? During the input is negative off cycle. During the input is negative off cycle, what will happen? Bottom is phase and the top is neutral. Okay, during the time, so here is a flow from here to that one. So what will happen? Here is a reverse bias. So dash. It's a dash. Okay, it is a dash 0. It's nothing but you have if you are a very keen interest about that half wave rectifier, and you are studied about rectifier means you coming to know that one source to the load, and another one is a switch is only the switch is used. This is nothing but half wave controlled rectifier. So do you remember? I will draw the diagram. You, that's why mug up is not suitable, not helpful for you. See, this is a diagram. Okay, diode uncontrolled. First I will draw load and load to the close. This is called off wave, off wave, off wave. This is off wave uncontrolled rectifier. I want to controlled rectifier. This is called off wave controlled rectifier. So this part is, what is that one? Off wave controlled rectifier. That's all. This is a off wave controlled rectifier. So why I am telling these two concepts, SCR and GTO both also off wave only. Both also off wave only. Not any cause. It's not a full wave. If you want a full wave, means what you want to use? So one more SCR connected anti-parallelly. If you are connected, okay, the same circuit, I will going to connected one more SCR anti-parallelly. If I will go to connected, it means then it is called what about that one? You will going to get it about the full wave, So you will going to get the full wave. But is it rectifier? Means it's not a rectifier. You have to see that one. Recently you have studied about single phase, okay, AC voltage controller. The circuit is look like the single phase AC voltage controller. What is a single phase AC voltage controller? Source to that anti-parallel connected to SCR. It is a anti-parallel connected to SCR. That one connected to the load. It is called a single phase AC voltage controller. Okay, does it is rectifier? No. Why it is not rectifier? Because AC power supply positive half cycle, this one is closed. Negative half cycle through this one is closed. So it is similar to coming on that one. Okay, so this is about the concept about that one. Okay, single SCR connected to the AC power supply and two SCR is connected to the AC power supply. Okay, then yes, yeah, the next one more concept you want to revise, that is about the characteristics. Okay, so first one, before we go to the characteristics, what is the difference between MOSFET and the SCR? What is the difference? So SCR is a controlled on, uncontrolled off. SCR is a controlled on and a uncontrolled off. MOSFET is a controlled on and controlled off. Not only MOSFET, IGBT also. Point number one, please note down. MOSFET is a controlled on and controlled off. Both IGBT and MOSFET, this is a controlled on and controlled off. Okay, so a few of the point I will going to tell you. Okay, so SCR is a, what about SCR? SCR is a controlled on, okay, and uncontrolled off. Okay, then what about next one? GTO. We were discussing about GTO. Then GTO means what? GTO is the same SCR family. It about that one controlled on and, yeah, and controlled off. So this is about that one. But you can say it's a one is a controlled on, one is a controlled on. I will bold it. Okay, another is controlled off. So you can say it is another name is called a semi controlled device. Semi controlled. You can say another name they will going to say about semi controlled means SCR. Okay, then remaining devices you have seen next to one. Okay, MOSFET and IGBT. What about these two devices? Means it is the same. So what is the device? This both the device is a controlled on and controlled off. That is a device. Okay, of so both also controlled, like about the GTO. Then what is the next one differentiation you have? See, these two devices is a current control device. Current control device. So what about this device? Means this two is a, okay, it's called a voltage control device. Okay, we'll go ahead and that one. These two we're going to discuss now. Okay, what is the current control device? Just you will going to recap it. So first one is I will going to draw. Okay, SCR, and SCR I will going to draw. Okay, here is a SCR is there. In the SCR is a gate terminal. Okay, through resistance gate terminal I got connected, or triggering method, or RC triggering method, or UJT triggering method. Any one of the triggering method used to, you will going to give the power supply. Once you will going to give the power supply, it will going to on. Yes. So whenever you will going to vary this resistance or the source, here the flow of the current is varied. The flow of the current is varied. That's why you have studied about latching current, holding current. Okay, minimum current is required to turn on. So that is about latching current. It is a turn on. So minimum current is needed. Okay, once you turn on, once you will going to apply that one 3.54 milliamperes. Once you will want to apply on, then it is on. Once it you are going to apply, then only it is on. Okay, so this is about the triggering. Okay, triggering method. Okay, then yes, then what else? Yeah, current control device we were discussed. So gate terminal, you will going to apply the apply variation of the resistance. Okay, if we're going to, I will going to simply say, Okay, so gate resistance, when you will going to vary the gate resistance, what will happen? It is directly proportional to that current. Okay, here is what about gate resistance is directly proportional to the voltage. So gate resistance